Today we're going to be going over chapter 2.3, converting fractions and decimals. Your essential question is how can you convert between fractions and decimals? Hopefully this is a review from 6th grade or prior grades, and it is not completely new to you. Switching between fractions to decimals and decimals to fractions. First, we're going to talk about what is a rational number. And we're going to use this Freyer model, right? We're going to fill it out. So here in the center, we're going to say rational number. The definition is a number that can be written as a ratio of two integers. Facts, characteristics. The denominator cannot be 0. So if it is a fraction, your denominator cannot be 0. And it includes terminating and repeating decimals. So terminating decimals means a decimal that ends. Repeating decimal is a decimal that never ends. Here's some examples. 4/7, -5/1, 0.3, and it has this line over it because it's a repeating. And then, right, we have 0.37 converted to a fraction is 37/100. So these are all examples of rational numbers. Pi is an example of a non-rational number. And 0 is also a non-example. 0 divided by 6, right, would give me 0. Now you're going to go ahead and you're going to fill out this foldable. So I'm going to show you how do we convert a rational number. So on this side right here, you're going to have how to turn a fraction to a decimal. And on the right side, how to go the opposite way, from the decimal to the fraction. All right, so I have 2/9. And we're going to go ahead and divide the numerator by the denominator. So let's go ahead and I'm going to show you how we would do that. Now, a fraction is just a division problem. So if you see 2/9, you could also read it as 2/9 or 2 divided by 9. All right, this line right here that represents the fraction is a division problem. So if I have 2/9, this can also be written as 2 divided by 9. That's another way of writing it. Okay, how we're going to turn this into a decimal is you're going to use log division. So the numerator, the number on the top of the fraction, essentially you can think of it as it falls, and you're going to have 9. And inside this log division house, you're going to have the 2. So it's like if you were taking this and tipping it over. This falls, the 2 is now here, and you just draw the house around it. Okay, now, for log division, some of you might get confused here because you would think, well, how much times is 9 going to 2? It can't. 9 is bigger than 2. It's fine. That means we're going to put a 0 here. And since we're going to keep going, I'm going to go ahead and bring a decimal down here, and you're going to also bring it up and write the decimal right up here. You're going to make sure it follows you straight up there. And one thing that I am forgetting is a 0. As you can see, now 9 doesn't go into 2, but it does go into 20. How many times? Well, you have to think 9 multiplied by what gives me as close to 20 without going over. Well, that's 2. 9 times 2 is the same as 9 plus 9. It's going to give me 18. And that's going to give me a 2. So I could bring another 2 down. But look, here's the problem. I had the 20 here, and now I have a 20 again. What does that tell me, since the same number showed up here and then it showed up again down here? Well, it means that this, if I keep going, I'm going to put another 2, and it's going to get 18, and I'm going to get another 2. So that means this is a repeating decimal. So your answer for this would be 0.2 with the line over it repeating. So inside your foldable, just go ahead and write this example. If you need to, you can pause it and rewind it so you can see what I did. If you have any questions, let me know. But this 2 fell. It's like you tip this fraction over, and the 2 goes inside the long division house when you are repeating. This is a repeating decimal, so this line goes over it. Okay, now for our next example, in your foldable, you have a decimal, and we're going to convert it to a fraction. I'm not sure which one you have here since it doesn't show, but let's go ahead and try. Let's try 0.36 if that's it. If it's not, it's fine. All right, so it says express the decimal as a fraction. So your first step, I have that decimal. I'm going to put it as a fraction, write it as a fraction by putting a 1 under it. So I'm going to put it over 1, like so. Now, it says multiply the top and bottom by 10 for every number after the decimal point. So after the decimal, I have 2 numbers. So 10 times 10 would be 100. So I can multiply the bottom, the denominator, and my numerator by 100. Well, 36 multiplied by 100 is the same as moving this decimal to the right 2 spots. So I would get 36 over 100 times 1 just gives me 100. Now this next part says simplify or reduce the fraction. What that means is it's telling us to divide it by anything that can go into both of these. So one way of doing that would be by utilizing a factor tree. I know, let's see, 4 times 9 gives me 36. Break this down even more. I have 2 multiplied by 2 gives me 9. And if I'm going to break down the 9, 3 multiplied by 3 gives me 9. Now I'm going to do the same thing, but for 100. So let's say, okay, well, let's do 2 easy. I know 2 multiplied by 50 gives me, and then the 2, we're going to leave that alone. We're going to go with 50. 2 multiplied by 25. And then this is 5 times 5. So what we're going to do is we're going to look at that last part of the tree. And let's see what numbers they have in common. So I see 3s here and 5s, so not the 5s. Look, there's a 2 here and there's another 2. 2 times 2 gives me 4. 2 times 2 gives me 4. So that means the top and bottom, the numerator and the denominator, could be divided by 4. If you don't know that, these are even numbers. Now, any even number can be divided by 2, right? You could have just cut it in half. We just found out that 4 actually works. So let's go ahead and divide this by 4. Now, some number times 4 gives me 36. Well, I know that's 9. Some number times 4 gives me 100. So if you don't know what 100 divided by 4 is, hopefully you can think of what number multiplied by 4 gives me 100. And that would be 25. So your answer would be 9 over 25. Now, there's a different way of doing this. Actually, let's go ahead and erase the page. If I choose the same number, let's see, 0.36. Let's try that again. Okay. Well, I know that there, after this decimal, there's 1, 2 digits. So I'm going to put it over a 1. And after this decimal, there was 2 digits. So 1, 2. This is also the place value. This is the tenths, and this is the hundredths. So you can do it like that as well. I know there's 2 digits or 2 numbers after my decimal. So that means I'm going to put 2 zeros. And I'm going to go ahead and erase the 0 and the decimal. So now I have the 36 over 100. Now we have to simplify it. Well, if you know your multiplication facts, like I said, it's a lot easier. If not, you can try the factor trees. If not, recognizing that these are even numbers will help. So remember, my even numbers are 0, 2, 4, 6. So this is a 6, this is a 0. Divide these by 2. That'll give me 50. This will give me 18. These are still even numbers, so I'm going to have to cut them in half again. And you'll get the same thing that we got last time, 9 over 25. So either way works. This is, I think I personally like this one. I know that 0.36 is 36 over 100. I already have it memorized. So hopefully you will memorize it as well. Here's some more examples. So this is a mixed number that they turned into an improper fraction. So remember to do that. You can do 2 multiplied by 4 gives me 8. And then add the numerator, gives you 9. So 2 by 4 gives me 8. Plus 1 is 9. Negative 9 over 4. The top number, remember this fraction is going to tip over, like the last example that I showed you. And then 9 is going to go in here. And then they show you an example of doing long division. There is no remainder. So this is your answer. And we can't forget the negative. I know another way of doing this, I'm going to show you real quick, that I think is actually a little bit simpler if you know what 1/4 is. So let's say, look at the whole number that you have here. The whole number is -2, not the fraction, the whole, -2. Well, you can think of that as -2, and then I'm going to put a decimal. Now I just have to focus on the 1/4. Well, hopefully 1/4, you'll know that it's 25 cents. So after the decimal, you just put 0.25, because it's the same thing. If you don't know, then you just use long division. Remember, the top number falls. You use long division on this short fraction. This goes into 0 times. 4 goes into 10 twice, gives me 8. Bring down the 0. 4 goes into 25 times. So I got 0.25. And you just add it at the end of that 2. So another way, if you don't want to turn it into an improper fraction first, you can just put the whole number in front of the decimal, and anything that you get from doing division from the fraction would come after your decimal. So that's another way. Writing it as a decimal, remember the numerator, it's like this fraction. If it falls, like the 5 falls down here, and then you put the long division house over it, like so. Okay, so we have some examples here, and then that'll be it. So let's see. Let's go ahead and try these real quick. See how fast we can do them. All right, so the first one, write the rational number as a decimal, -6/5. Because it's a negative, your answer is going to be negative. Same with this one, same with this one, and this will be our only positive answer. Okay, so let's see, -6/5. Remember, this is going to tilt. It's as if this just falls, right? And once you get that to fall, I have 5 and 6. How much has this 5 going to 6? Well, the closest you can get to it is 1. 5 multiplied by 1, 5. The 1 left over. That's where we're going to bring in the decimals so we can keep going. How much has this 5 going to 10? Twice. 5 times 2 gives me 10, and that cancels out. Now, remember, we had a negative here, so it would be -1.2. For the next one, remember, this is a -7 3/8. Let's try it. Like I suggested, I have a whole number. Instead of turning this into an improper fraction, I know my answer is going to look like -7 point something. So now let's just focus on the 3/8. Well, this fraction is going to tilt over. This is going to fall, and your 3 is going to be down here. So it will look like this because this fell, right? This fell here, and you just drew the house around it. Now, 8 does not go into 3, so that's a 0. The closest 8 goes into 30 would be 3 times with 24. Leaves the remainder of a 6. Bring down another 0. Closest 8 multiplied by what gives you 60. If you honestly don't know, check a multiplication table in the back of your composition book. If you don't have a composition book, let's look one up on the computer. But I want you to try to have these simple multiplication facts memorized. It will help you out a lot. So there's a 7. I have a 4, and I'm going to bring down one more. And it's going to end here. 0 multiplied by 5 will give me 40. And that's it. So what I'm going to do now, we got 0.375. But remember, there's actually a 7 here. So whatever I got for the decimal, I'm just going to add it on here. 3, 7. So this will be your answer for that one. All right, let's do one more from the bottom. Where it says, actually, we can do both of them. Write the decimal as a fraction or a mixed number in simplest form. All right, well, let's go ahead and try how I mentioned earlier. This has, I know my answer is going to be a negative. And negative point, okay, I'm going to put it over a 1. Here's my decimal. There's one number after the decimal, so it's going to be 1, 0. And then I'm simply going to erase the decimal. So your fraction is 7/10. This is odd. This is even. 7 is prime, so there's nothing that goes into it. So, and we had a negative in front, so your answer is -7/10. And you're done. It's as simple as that. Let's try the next one, where you have 0.125 over 1. How many numbers do I have after this decimal or digits? I have 1, 2, 3. So it means I'm going to put 1, 2, 3 zeros. And now I'm going to erase that. And there you go. There's my fraction. Now, this fraction is not in simplest form. I can still divide it by some things. Instead of doing a factor tree, it's a lot easier if we know some of our rules. For example, anything that ends with a 5 or a 0 means it can be divided by 5. So let's go ahead and try this and see what it gives me. This is going to give me 2, the remainder of 2. Here I'm showing you the shortcut of long division. 5 multiplied by what gives me 25. And it's 5. So in the numerator, I have a 25 over. Now let's do the same thing, but this time with 1,000. All right, well, how many times does 5 go into 1? Doesn't. 5 go into 10. 2 times. 5 go into 0. Right here, 5 go into 0. So I get 25 over 200. The problem with dividing this by 5 is that we did not divide it by the GCF, by the greatest common factor. So it's saying Big Ideas, if Big Ideas asked you to put this in simplest form and you try to leave it like this, it still is not in simplest form. This can actually be divided by 25. So this would be a 1 over, and then if you do 25, 200 divided by 25, it should be 8. 8 times 2, 6, plus 4 is 20. So your answer will be 8. 1 over 8. All right, so just be careful about what you divide it by. We could have kept dividing it by 5. It would have just done it 2 more times in a row. If you need help, let me know. This is your assignment for today, Big Ideas 2.3. You can also refer back to this video if I'm busy helping somebody else in the meantime until I get to you. All right, let me know if you need help.